Array relationship is a set of ordered pairs. Okay. The x coordinate is which one, first or second, when you list a point? Yeah, it's always the first one. Does anyone remember the fancy name for the x coordinate? The x coordinate starts with a D. Oh, goodness. Domain height. And the range, I just gave the second one. Whoopsies. The range is the Y, which is always listed second. So you guys, let's talk domain and range of these little graphs. Of this graph here, domain is those x coordinates, or where does this graph exist on the x-axis? Don't forget, x-axis is this one. So that means how far left and right are we going on this graph? What would you say? How far left is this graph going? Forever. How would I say it forever left mathematically? Negative infinity. She says from negative infinity, I'm putting a parenthesis with that because a parenthesis means I'm not including that value. Infinity is not actually a number. I can never be infinity. So that'll always have a parenthesis. Ajani, how far do you think we're going to the right? Positive infinity. Some people might write it like this. Others might write, they might say all real numbers, which is that fancy R. That fancy R has two little psh, psh, and then the R. What about the range? How about the range? Range is always talking about that y-axis. So that's always talking about this up and down axis. How far down and how far up? Range. How far down is this graph going? Negative infinity. How far up is this graph going? You know it. So did I write these from smallest to biggest every time? Yeah. You always want your parentheses, your number set to just go from smallest to biggest. Or you could write all reals for that one. Q. How about this cute little absolute value graph? This would be the absolute value of x. Domain is the x-axis, the x's. How far left and how far right would you say this graph will go? Yeah, all real numbers, negative infinity to positive infinity. I agree. Whoa, I am messing things up. Okay, the range. How about the range on this one? How low on that y-axis am I going?
0.
Nice, you guys. I'm at 0. How high am I going to go? Infinitely high. Very good. So you guys, on that 0, do you think I should put a parenthesis or a bracket? Yeah, we're going to bracket this up because it's actually at 0. I know it's not, doesn't look like a point, but because it's not an open circle, we're going to put a bracket. So maybe you remind yourself, if it's ever, closed or included, we do a bracket. If it's ever an open circle or infinity, we do a parenthesis. Okay, let's take a peek at this guy. For the beluga whale from Finding Dory sticker, the domain of this one, how far left on that x-axis did this go? -6. To infinity. Elliot, I love it. Is my -6 going to have a bracket or a parenthesis? It's going to have a bracket. You guys are good. Bets, how about the range? How far down on the y-axis would that go?
1.
Yes, she's like, okay, as low as it's going is 1. And then even though it looks like it's kind of leveling off, it keeps going up, up, up. So we're going to say 1, 2. You got it, girl. And that 1, we're going to throw that bracket on. You got it, because it's closed. How about the domain of this one? Let's first deal with this part. How far left is that one going? We can work through this together. How far left on that x-axis? Awesome. It's going negative infinity. And then on this one, as I go right, where does it stop on the x-axis? -2. You guys got it. Closed or open, parenthesis or bracket at -2. Yeah, whenever it's a closed circle, we'll go bracket. Then we say, and it picks up at what x to what x? Very good. He's like, okay, at -1, and then it keeps going to the right, which is infinity. At -1, do we want a parenthesis or a bracket? You guys are good. Okay, 8th period, you are bringing the heat. I appreciate it. The range. This one we're going to get in a fist fight about, I think. The range on this, I think, is really hard. How low do we go? Yeah, -3. I agree with that, Elliot. So I feel good about that. -3, you cool if I bracket that up? How high does that go? Okay, so I feel like we're not getting in a fist fight about that, right? But you guys, now we don't have to put anything else. And why the heck not? Let's think about it. How? Exactly. Well said, Elliot. What would we write for this one? What's my lowest y and what's my highest y? We don't have to write this part down, and I'll tell you why. What's the lowest y there? 1. What's the highest y? Infinity. And that 1 would be an open circle, correct? So I'm going to do a parenthesis. Why do I not need this? This is redundant, and here's why. If I say the range, the y values go from -3 to infinity, does that, as Elliot say, encompass 1 to infinity? Is 1 to infinity included in there? It is, so that's why we don't need it. But you might say, hello, why didn't we do that like right above it? Well, is -1 to infinity encompassed there? Like there's no overlap there. You know what I mean? So when there's overlap, we can be more concise. If we were to add extra, it'd just be a little redundant. All right, a function. Anyone remember which one's independent versus which one's dependent? Which one's the independent variable, x or y? Roland, what'd you say? Oh, it wasn't. Ben, what'd you say? Is which one? You got it. Oh gosh, why would I put these in my right hand? I can't write now. X is independent. X is independent. That means y is dependent. This is a very ugly y. Let's put these here. So if this is my y. All right, you guys, you're going to learn from me. I do not like textbook definitions. When I was a student, this did not mean anything to me about what makes a function a function. Blech. In simple terms, something that's a function is just the x value doesn't repeat. That's what makes a function a function. The x does not repeat. So in order to figure out if we have a function, let's go name our x's. The domain is just the x's. What are the x's in this first example? What coordinate, what would we say? We're going to do our fancy little bracket. -3, 4, and 2. Some people might want to put that in numerical order. I don't care either way. Your brackets are probably going to be prettier than mine. I'm trying to do these brackets. I just don't have the patience. You know what I'm saying? I don't have the patience. Okay, those are the x's. What are the y's? Love it. 0, -2, -6. Did any of my x's repeat? We had a -3, a 4, and a 2. Who said no? You're exactly right, Bets. She's like, yeah, none of them repeated. If my x doesn't repeat, I have a function. Exactly, Betsy. Thank you. We got it. Let's look ahead. Let's jump on the next one. Let's answer, is it a function or not, before we even do domain and range. Is it going to be a function? What do we think? Nah, what do we think? Yeah, so we're going to say no, and maybe it just helps you to just kind of draw these arrows like those 4's repeated. Those 4's are no good. Those 4's are my x's. Do I care about the y's repeating? Not one bit. So what are those domains? 4, 9, -9. And you guys, if someone wrote the 4 twice, great, I don't care. Finn, if you want to write 4, 4, 9, -9, go for it. Doesn't matter. I'm a little lazy. I'm only going to write it once. The range on this one, -2, 2, -3, 3. We got this. Flip it when you... What if I didn't give you the actual coordinates written out? What if I gave you a graph? Does anyone remember the name of the test to determine from a graph if something's a function or not?
Variable line test.
Ooh, something line test. Yes, there you go, Sierra. Vertical line test. And what the heck does a vertical line test mean? I have it right here. If a vertical line goes through a function once, then it is or is not a function. What do you think? If it only goes through the function once, yay or nay? Yeah, I heard is. If a vertical line only goes through it once, then it is a function. So a little example of that, check out these points. If I do a vertical line, I go, boom, vertical line, hit that point once, only through 1 point, 1 point, 1 point, 1 point. That's why that one, those points represent a function. And then this guy, cute little graph, when I put a vertical line through it, It goes through it twice. Therefore, that's not a function. Cool? So this one is not a function versus it is. Let's go take a peek at B before we do A or the last one. Do you think that B represents a function? What if I draw a vertical line here? How many times did it go through it? Here? Here? We feeling good? Is it a function? Holler, we say yes. That one's a function. Let's act like A is just the straight line with no shaded part. If it was just this, is it a function? Yeah, because the vertical line, boom, only goes through it once. But what the heck is all this shaded stuff representing? When you shade it in, like with an inequality, like, what are those? Yeah, they're solutions, and that means that they're points. So these are like technically infinitely many points. So when I draw a vertical line through this, am I going through more than one point? Yeah, so this one's tricky. This one's actually not a function. I think that's rude. You know? Let's do 3 more and then I'm out of your face, you guys. On number 1, what the heck does this mean? If it says, hey, f of x is given, what's f of -4? If this was an x, what do you think I need to replace every single x with? You know it, people. Let's do it. So I'm going to put a -4 in for every single x. So, and guys, we're going to do this without a calculator because we can, because we're together. We got lots of brains together. If you were at home and you used a calculator, I would too. Okay, I got to be honest. I would too. But let's just grind this out together. We got this. Any negative to an odd exponent. You guys, negative number to an odd exponent. Stay negative, go positive. Yeah, any negative to an odd will always stay negative. Okay, so we know we've got, it's going to be negative, 4 cubed. 4 times 4 is 16 times 4. That's it. Very good. Boom. Minus 7 times, what about a -4 squared? Wait. Oh my God. Wow. I was waiting for someone to say 49. And I was like, 16. No, -4 squared is 16. I think I was thinking 7 squared. Okay, thank you for being better than me. -2 times -4? We got 8. Love it. You guys, 3 times 64. If you're like, that's not in my multiplication timetables, I hear you. Here's what we got to do. We got to just go off to the side and remind ourselves how to multiply that stuff. And you're like, I haven't done this in a long time. I get it. That's why we're going to do it now. What's that 4 times 3? 12. And remember, it's that whole 2 carry the 1. You know what I'm saying? 6 times 3? 18. And then you add that cute little 1 we carried. What do we got?
19.
You got it. 192. Positive or negative? Yeah, negative 192. 16 times 7. Don't know if I've ever done that in my entire life. 6 times 7? 42. We carry that cute little 4. 7 times 1? Add that 4. 11. Woo! So we got minus 112 plus my 8. I know, guys. It is literally 248, and I'm making us do this in our head. This is insane. Here we go. Negative 192 minus 112. They're both negative, so I'm basically just going to add them up and throw the negative in front. 192 plus 112. 304. Nice job. Negative 304. Add 8. Negative 296. Good job, you gues. Would I ever give that to you on a quiz or anything without a calculator? No. I'm just doing it together because it's good for our brain. And we do not have time to kill. Here we go. What are these things called? Absolute value bars. We don't have to worry about them until the final answer, guys. So we're going to just plug that 9 in, and we're going to really just ignore them. 6 times 9 minus 77. Without a calc, 6 times 9. Oh my gosh, I want to say 72. I got to go home, y'all. 54 minus 77 is negative 23. Now, once you finally have one answer left, that's when we get to acknowledge the bars. Absolute value of negative 23. Boom. Anything in the bars will always become positive. If it was positive, it stays positive. I got one last one to do before we're done. What happens when I got to plug this J minus C in there? That's annoying, isn't it? We got to do a little C minus 5. Why did I say J minus C? Guys, I legit need to go home. It is time for today to be over. If we've got that squared, would I just take this 2 and distribute it? I can't do that, remember? Doesn't it need to be C minus 5 times C minus 5? Yeah, so I'm going to just write it like that to save myself a step. Then I got negative 7 times C minus 5, and then a plus 4. Let's go distribute that sucker. What are we going to get when we distribute C minus 5 times C minus 5? We got C squared minus 5C minus 5 more C. You down with minus 10C there? Plus or minus 25? Nice. Then, minus 7C plus 35 plus 4. Final answer is just going to be combining some like terms. We got C squared minus 17C plus, you got it, people. Well done. Homework is going to be pages 3 and 4, only up through problem 47. And here are the answers for you to look back on. Check your work and come in with questions tomorrow.